Alright, so today we're going to talk about ways to prove that two triangles are congruent. So before we jump into this, I want to remind us of a few ways to prove angles and ways to prove two segments. Alright, so ways to prove two angles, if we have a reflexive angle, which is one that's shared, then we can have, if they're equal, then we know they're congruent, and guys, that's just a definition of congruency. I want to remind you vertical angles are congruent, all right angles are congruent, and if you have an angle bisector, then we know that that's going to chop it into two congruent angles, just by definition. That's what an angle bisector does. Then from the last unit, we have corresponding alternate interior, alternate exterior, and then those are proven if you have two parallel lines. If you have two angles who are congruent to the same angle, then they are also congruent. And guys, that's transitive property of congruency. On the last unit, we talked about transitive property of parallel lines, where if two lines are parallel, then they're automatically parallel to the third. Kind of the same scenario here. Two angles are congruent to the same angle, then they are also congruent. If we have two angles that are supplemental to the same angle or congruent angles, then they are congruent. And if you have two angles that are complementary to the same angle or congruent angles, they are congruent. Guys, we don't use these three very often, but I just wanted to make you aware of them. If two sides of one triangle are congruent to two angles of the opposite sides are also congruent. That's the isosceles triangle theorem that we talked about in the video from yesterday's unit. Perpendicular lines form four right angles, and remember, we know all right angles are congruent. Alright, so those are ways to prove angles. So let's talk about ways to prove segments are congruent. Again, you can have a reflexive segment where you share the side of a triangle. We also know equal means congruency. If a point is a midpoint, guys, remind yourself what midpoint means. That means two segments are congruent. If you have a segment bisector is going to chop it into two pieces, which means that guy is essentially your midpoint. If you have a perpendicular bisector, it's going to go through the midpoint. If two angles of one triangle are congruent, then that means the two sides opposite of those angles are congruent. And guys, that comes straight from isosceles triangle converse theorem, where we introduced both of those in yesterday's unit. So if you want to go back and watch that video, we talked about that theorem and gave some examples. Alright, so today what we're going to do is talk about ways to prove two triangles are congruent. And the huge takeaway from this is you have to have three items of congruency. Three items of congruency. So it's a combination of sides and angles that prove two triangles are congruent. So in order to prove side, 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 you must have all three pairs of corresponding sides congruent. So notice right here, we have two triangles that we're trying to prove are congruent. These two pieces are congruent, these two pieces are congruent, and these two pieces are congruent. Therefore, because we have all three sides that are congruent, we can prove that both of those are the same triangle by the postulate side, side, side. Side, side, side. Alright, then we have side, angle, side. Notice SAS, side, angle, side. This is where you must have two pairs of congruent sides and one pair of angles that are included. Alright, that's the big kicker right there. So if I were going to highlight any word or circle any word, it would be the word included. So notice that the angle must be between the two sides. Included means the angle must be between the two sides. So notice, I want you to think of these two angles as like a door. And if I opened this door, do you see how the angle is created in between from the closed door to the opened? So here are my two sides that are congruent, and then my base is congruent. So I've got my two sides, but the angle must be in between those two sides, formed where those two sides meet. See how these two sides meet in this corner, and then there's our congruent angle. Same thing goes for angle, side, angle. two pairs of angles are congruent, and the pair of corresponding sides includes the angle. So it includes the congruent side. So notice we have two angles that are congruent, and the side that is congruent is listed between them. So the side is between the two congruent angles. So we have two congruent angles, which are our base angles, and the side that's congruent is listed between. So notice how your postulate angle, side, angle looks a lot like your triangle, angle, side, angle. All right, angle, angle, side, you must have two pairs of corresponding angles that are congruent and one pair of corresponding sides. All right, but this is the thing. Notice the difference between those. In this one, the side is between the two angles, and this one, the side is on the outside. So here, we have two angles, but then the side is out here on its own. Two angles, the side is out here on its own. So you could have said SAA or AAS. And then our last one is hypotenuse leg. So I tell my students, anytime they see a right angle in a triangle, their first thought should be, is this a hypotenuse leg? So you must have a right triangle and a pair of hypotenuses with one pair of legs congruent. So remember, guys, you can take your pencil, draw your arrow out of the right angle, and it points to the hypotenuse every single time. So be careful, because sometimes students confuse hypotenuse leg with angle, side, angle. So we have an angle, we have a side, and we have a side. But this second side over here is actually the hypotenuse. So we have a hypotenuse that's congruent, and then we have a leg that's congruent. So now, guys, what you're going to do is take those postulates and theorems, and you're going to apply them when given a diagram. So here, you're given this line AD is parallel to this line CE, and we want to prove that B is a midpoint. This guy is a midpoint between this line. So the first thing you're going to do is write your congruency statement. We're trying to prove triangle ABD is congruent to triangle CBE. So that's what I'm telling you. Here's your congruency statement. And so it says state which two triangles are congruent and why. All right, so the first thing that we talk about are vertical angles. So these angles right here are vertical angles. We know that they are congruent. And then if that's the case, then we know AB is congruent to BC, and we know angle 1 is congruent to angle 4 because of alternate interior angles. I'm sorry, 1 and 2. I was looking at that from the side. So angle 1 and angle 2 would be alternate interior. Then we could use our vertical, and then we could use the side, AB is congruent to BC, to prove angle, side, angle. You could also prove angle, angle, side by saying AB is congruent to BC, angle 1 is congruent to angle 2, but also angle 3 is congruent to angle 4 based off of alternate interior angles are congruent, because these lines are parallel. Example 2, I'm telling you triangle RSU is congruent to triangle TSV. I'm telling you that. So guys, if I'm telling you that, then you can use that congruency statement to tell me that US is congruent to SV. So US is congruent to SV. And then angles 1 and 2 are vertical angles, so we know that they are congruent. So therefore it proves angle, angle, side. Angle, angle, side. Angle, angle, side. So you were given that RU is perpendicular to RT, and RT is perpendicular to TV, therefore S is the midpoint. And example 3, you're given that AB is congruent to BC, so AB is congruent to BC, and you're given that BD bisects ABC. So if it's bisect, then we know those two angles are the same. All right, so in order to prove angle side angle, we're going to say angles 1 and 2 are congruent because of isosceles triangle theorem. So guys, remember, isosceles triangle theorem says that if these two legs are congruent, their base angles are congruent. So therefore 1 and 2 are congruent. And we know 3 and 4 are congruent because it's an angle bisector. So that proves angle side angle. Or we could prove side angle side by saying AB is congruent to BC. That was a given. 3 and 4 are congruent because of angle bisector. And then BD is a reflexive leg. So that would be side angle side.